Hello and welcome. This how-to is about a Microsoft Power Apps Canvas solution that performs a Wordle computation. Effectively, it is the engine. In it, you enter a guess and an answer, and it returns a string telling you the match. If the guess character is in the same position as the answer, you'll get the letter G. If it is in the phrase but not in the same position, you'll get a Y. And finally, if the character in your guess is nowhere to be found in the answer, you'll get a B for black. My goal was to create a solution that catered for duplicates. I could not find one for Power Apps, and asking Copilot returned a blank answer. Who knows, maybe after this how-to, Copilot will ingest this and be able to help others. Let me demonstrate what I mean by duplicates. Assuming my answer is Abby and the guess is babes. When I click on Wordle it, I get the output as yellow, yellow, green, green, black. The first two characters of each are there but not in the right order. The next two, the B and the E, are there and in the correct order, and the S is black because it's nowhere to be found in the answer. Now let's try another example. If I put babes in the answer and I put A-triple-B-Y in the guess and I Wordle it, the answer I get is YY because the first two are there but not in the right order. I get a green because the third B is identical, and then I get two blacks. The third B returns as black because the first two have consumed all the B's in the answer. What I mean when we say checking for duplicates. If we stop this application, what we have are a couple of labels and text boxes, a button, output, which we've discussed, and exact match, which I will discuss. Here there are two examples which I dry run. If in the answer you have Abby and in the guess you have babes, the first thing the solution does is it creates a variable called exact match in which it highlights those positions where there is an exact match. If you look at the comparison here, it is the third and fourth character. In the code I'm going to share very soon, this is in line 4. Once I know where these positions are, I take guess and answer and replace those positions with characters that cannot be used as answer or guess. And if I scroll down, you will see that I have a note that these are reserved symbols. This way, I am eliminating those characters from the equation. What remains after this stage, lines 8 and 9, are therefore either the yellows or the blacks. I then start to loop. I have 5 characters, so 5 times. I will go through one character at a time. I start with the first position, I take a B, and I say, is there a B in the string? At this point, it is AB --Y. And I get a yes, there is. So I put a Y. A G it can't be, because these have been eliminated at the time I reach this position. After I do that, I take that B and strike it out. I turn it into a dash. That means that B has been matched to something. I then take the second character, which is the A. I say, right, is this A in guess, the second character, found in the string A --Y? It's yes, so okay, I have a second Y. I strike it out, turn it into a dash, and then I move to the third character. Now, before, I always check exact match, and if it's a G, that's green. There's no need to go further. I just plug the G, which I had extracted, up here. And I move one up, another G, I plug it in. I then move to position 5, which is the S, and I say, is there an S in what remains? --Y? No. So that's black. And that gives the answer. Exact match, as you can see, is this variable up here. If I swap the terms, I added another B to Abby, the same reasoning goes. Here I only therefore match on 1, which is the third position, strike those out, And then I repeat the process. B, yes, strike it out. And I update as I go along. Let's look at the code. Most of the action is on the button press, and I have two global variables. These are output and named formula exact match, and they are set to the result of two functions we're going to look at. The first is exact match, in which I will pass the parameters of txt answer text, which is this one, and txt guess. And the output they give me are being shown here. Let's have a look at the named function result. This is found in apps under formulas, and I want to clarify that user-defined functions are an experimental feature and you have to explicitly enable them in your Power-Ups project. One of the differences between a declarative and a procedural language I found was that it was very difficult to have temporary or working variables in your solution. And this proved for me a bit of a challenge until I managed to wrap my head around it. When I'm using a procedural language, inside a procedure I can create scratch variables, temporary variables, and populate them. Here I could not. So I had to figure out a way to go about this. And this I used the with. This is my function name, the parameters, and it returns a text. The with statement allows you to create working variables. I have with, then indented another with, then indented another with, then indented another with. Because the with has limited scope. For me, a solution would have been the ability to have something like a modular with, where I can define, and that lives until this function terminates. My justification for this is that, for example, as I go along from one position to another, answer has to be updated. Answer has to have the characters changed to dashes. So in my case, that meant that in order to preserve answer from one position to the next, I had to embed one with to another. What I am doing is I am calling an exact match. It builds a list of those entries where there is an exact match. I'm using the concat function for all, and that will loop for a number of times, this being the length of guess. We know it's 5, so it will loop for 5 times, and in that sequence, using a with, I'm setting up operational variables. I'm taking the character, and value is the variable that stores the sequence number. Each time to the loop, I store the character, I store the guess at that same position, and then say if guesscar is anscar, put a G, otherwise put an underscore to indicate no match. You will see that with the with, the scope of anscar and guesscar remain whilst they are in the body of the with. Out here, there is no anscar and guesscar. The accumulation of the for all, which in this case is either the G or the underscore, is held in a variable called value. Again, value is used by a number of functions, and that is what is returned. Armed with that, I then have another with where I am going through answer and guess, calling another function, the same function though different parameters, and if remove exact match, that in this particular case I'm concatenating. I'm using a for all for the length of int string, which I know is 5, and I'm extracting each character. I am taking from a template, which I've passed as a parameter, that character as well. And if it is a G, I replace whatever is there with this character. Otherwise, I retain the character itself. If I go up here, what these two lines are doing is that for every position there is a G in the exact match. One has a dash and the other has an asterisk. One comment is that I have a width here and a width here. Why couldn't I have joined these together? Because the width, the way they are evaluated, is that they become available outside the curly bracket, meaning that if these two were in the same block, even though if I had something along these lines, exact match is not yet available to the function. I create this, and now since it's within another width, now it's available. Once I get to this stage, I'm going to work one position at a time. Now, if we zoom out a bit on this, you'll see that position 1 and position 2 and position 3 and position 4 and all of the positions, they are practically identical with the exception of the position I'm picking. I could not find a way to put this into a loop. So with 5, you have a lengthy amount of code. If this was 50, I don't think it would have been doable. I recall from many years ago when I had to use assembly, we had in assembly the ability to define a block of code that at the compilation stage gets put into the body. It was called a macro. It would be nice if, with power-ups, unless there is a workaround to having this in a looped manner, to have this functionality where I would take this chunk of code, I could pass a parameter, and I could have something like this, and I would replace this with pos. And when the code is being interpreted, everywhere it finds one of these proc pos, it just substitutes the text, replacing the parameter I had. So in my code, rather than have this, I would have said to whatever. All this code is simplified, is easy to maintain. If I need to change a line, I could at least change one place, not have to change in 5. And in my opinion, it adds readability. Power-ups is case sensitive. Many hint that it's a close cousin to Excel. And Excel is not case sensitive. It would help if, for example, this if got auto-corrected. Here, there is an app checker. And if I click that, I can open monitor and I run this and I Wordle it. I do get events that are happening. Another great feature would be the ability to show the current value of global variables and context variables after each user action and adjust their value without having to restart the program. Thank you for watching this Microsoft Power Apps HowTo. I hope that by following along, you can not only recreate the solution presented, but also enhance it and share your improvements with the community. Microsoft Power Apps is a declarative development solution aimed at low-code or no-code solutions. As we've seen in this how-to, there are new experimental features, and in this spirit, I hope that some of the suggestions and thoughts shared here will eventually become future experimental features. Such features will enhance power-ups and make it palatable to a wider audience, allowing those who join the power-ups bandwagon as no-code newbies to develop enhanced solutions, while those of us with a procedural programming background would find it more palatable. I welcome your thoughts and feedbacks on these topics. Please leave your comments below. I would appreciate if you could like, share, and subscribe to this channel, as it helps me create new content. Thank you and take care.